Hello, good afternoon, friends. All my viewers of watching my channel Flexomaster. Today we are going to continue with chapter number 23, corrugated board packaging. And here we start corrugated board packaging. Printing of corrugated board containers. Craft board is not an easy medium for high quality decoration and printing. It is typically a brown color and has a rough surface made more difficult by the fluting, which also creates an uneven surface. Plain corrugated cases are typically printed using flexographic printing. Flexographic printing applies pressure to the corrugated board to effect ink transfer. Compressing the flute structure can lead to a loss in potential compression strength. If top to bottom compression strength needs to be maximized, heavy and multiple color ink coverage should be avoided. Typically, alloy crushed paper color per color is about 0.1 millimeter. Water-based inks are typically used. There are various ways of improving print quality. A white craft liner provides a better background for printing. Oil-based inks provide a glossy finish and have good resistance. However, they need long drying times before further processing, which significantly delays production. Screen printing does not need the contact pressure of flexographic printing, which means it can cope better with uneven surfaces. It is also possible to laminate the entire container using lithographic printing. Alternatively, labels can be used to decorate a container. White top craft liner can also be pre-printed before it is converted to corrugated board. Pre-printing eliminates the problems of trying to print an assembled corrugated board. The usual minimum amount of pre-printing is 2 mil rolls or several tons of papers. This limits the process to fairly large production runs. There are obviously significant cost implications in the choice of print quality and the material needed to be achieved. However, this has been mitigated by the use of high quality post printing technology. The type of equipment is usually installed offline but can be linked with a die cutting unit. As with much of this industry, the basic process has roots well back into the last century, but it is now possible to produce good quality close registered process work due to the introduction of technical refinements. The print units use thin printing plates with flexible backing along with the vacuum transport system to reduce undulating surface strips. Finely engraved analog rolls to closely control ink deliveries, and individual driven modular print units to maintain color registration. Such equipment can be used to print upwards of 6 closely registered colors with a 38 lines per centimeter screen, resulting in good quality graphic reproduction. This is the case dimension expressed as inside dimension in the following order: length, width and the depth of the corrugated board. Here is the score dimension, score to score dimension. T represent material thickness, constant typically 1.6 millimeter for single wall design, which is K. A flat sheet laid out with the resulting folding dimension. Special board treatments. Most special treatments are concerned with maintaining container performance in humid and wet conditions. Particular tear, puncture and compression strength treatments can be added to the paper milling, applied to the liner or medium as it goes into the corrugator, or added to the finished container. The latter can be advantageous if the surface treatment might make gluing less effective. Thermoset resin, typically melamine based, can be added at the paper mill to provide greater water resistance. It is important not to exceed a content of 2% if the paper and resulting board is not to, to be too brittle, further treatment with acrylic coatings increase wet performance even further. Whilst these coatings provide good water repellency runoff, they are poor in terms of moisture vapor transfer. If the container is to be exposed to particularly wet condition, example, but it has to be spent some time outside, such as cases of trays used in the point of harvesting fresh produce, the liner may need to contain a polymer membrane embedded between two layers of paper. This removes the likelihood of overheating the polymer layer during the corrugating process. Avoid potential problems with gluing and printing. And now testing the corrugated board material. There is a range of tests of material containers and containers. Only the most commonly are noted here. Most board tests are described in methods provided by British Standards Institution and the Technical Association of the Pulp and Paper Industries, which is TAPI. Paper mills concentrate on meeting grammage and burst value requirements. There are no specific liner caliper requirements. However, there is a more move towards specific uh, however, there is a move towards specifications based on other aspects of performance. Example, edge crush test values. When conducting testing, it is important to be aware the mechanical strength of paper depends on the rate at which its load is applied. The faster a load is applied, the greater the ability of paper to withstand it. Dynamic compression strength is thus higher than static compression strength. In addition, under sustained and repeated loading paper fibers move and distort, further reducing strength. The creep behavior means that container tested, for example, at 500 kg load compression strength in the laboratory, a fast loading rate could be expected to fail in about a year when loaded to 250 kgs in the warehouse. One of the most important factors affecting the mechanical properties of paper is moisture content. It is therefore essential the paper testing always be undertaken at the same temperature and humidity. The internationally accepted standard is 50% related humidity and 23 degrees centigrade is the temperature. The moisture contents of paper depends on the humidity and temperature. Paper exhibits hysteresis, that is the equilibrium moisture content is slightly different depending on whether the equilibrium is approached from a higher a lower initial moisture content. See in the figure below the graph. Increasing moisture content leads to reduced compression strength. Increasing moisture content also leads to paper swelling, while drying makes it shrink. As an example, between 0 and 90% related humidity, dimensions can be changed by 0.8% in the MD and 1.6 in the CD. Poor humidity control can cause distortion in a blank, which can compromise subsequent folding into the final container. Uneven moisture content in the outer and inner liners can cause wrapping as the finished board is dried. Wrapping should not exceed 6 mm over a 300 mm span as measured according to the standard ASTM D4727. Their mechanical strength of testing are the range, Muhlenberg test, edge-wise compression test, box compression test is short span compression, and flat crush test, Concora medium test, thickness of corrugated board test, puncture resistance test. Testing the mechanical strength same. The Mullion burst test involves slowly applying hydraulic upward pressure to the fiberboard until the liner bursts and board is ruptured. The burst strength is measured in kilopascals. If the liners are different, it is important to test both sides. A drawback is that test is related to paper tensile strength, which may not be most important factor affecting the stiffness and compression strength of the material. As a result, edge-wise compression test is increasingly used as an alternative. This edge-wise test involves placing a specimen of board, typically 50 by 50 millimeter, vertically into compression test and apply a load until failure occurs. The ECT measures the stiffness of the combined facing and medium, and as a result it is better indicator of stacking strength. Using ECT measurement, case container strength can be calculated using simply Mikey formula. Case compression test is equal to 5.87 into ECT square root of BP into T. BP is inside case perimeter, where estimated RSC top bottom case compression strength is expressed in kilonewtons, ACT edge crush kilonewtons per meter, BP inside case meter and perimeter, sorry, and T combined board thickness. The flat crush test is similar to the edge compression test, except the specimen is compressed in the flat crush test. The test provides a measure of fluid rigidity. The box compression tester is platen with either 4 columns fixed head and a single central column floating head configuration. These columns have lead screws that drive the top plate of the platen downward. An erected box is placed centrally in the tester and platen is driven down until the point of failure is reacted and measured. This test can become particularly relevant when specifying suitable material combination. For multi-piece or perforated retail ready packs, it can be used for benchmarking and validation where theoretical calculations such as modified Mackey formula are unreliable due to the complexities of such packs. As there is a strong correlation between the in-plane compression strength of liner and fluting ECT values, the short span compression test was developed. This allows the ECT and hence the BCT values of given case to be extrapolated. The paper sample is clamped between the 4 segments of the apparatus, which has a 0.7 millimeter gap between the pairs of clamps. When the two pairs are driven together, length of the strip reduces and stress increase as the sample is short relative to its thickness. Buckling is prevented and the measured failure is due solely to compression. Either BCT values and ECT values can be used to specify the boards use a construct corrugated container. As a general rule, shippers interested in warehouse stacking strength find it advantageous to use BCT. Those shipping in rugged environments or where puncture resistance from product is a concern might also use the puncture test. The other properties of testing are it is water absorption, Cobb test, porosity, Corley Cobb test, and Benson test method, water resistance, ply separation test, machinability, coefficient of friction test. Cobb test measure surface water absorption or repellency. It describes the time required to soak a specific amount of water into a corrugated sheet. The standard unit is grams per square meter. The time may vary from 60 seconds to 30 minutes. The Cobb test is used as a various ways. Example, to investigate potential gluing problems where a reasonable degree of absorption is required, or degree of water repellency where containers may need a higher degree of water resistance. The Gurley porosity test uses the time it takes for a given volume of air to pass through a paper to measure porosity. The lower the number, the more porous the paper. The porous can vary from 2 seconds to 200 seconds, but averages between 10 and 20 seconds. The ply separation test evaluates the board resistance to ply separation when exposed to water. It is used mainly to the test the effectiveness of water resistance adhesives. It is important to be able to measure how easily corrugated board can be formed and how well it performs in loading. If board slides too easily, it is it will be hard to process and use to transport and stacking. One useful measure is coefficient of friction. One method of determining coefficient of friction involves placing a weighted piece of test material on a surface face with same material. The angle is gently increased until the material stiffs, at which point the angle is noted. The tangent of the average slide angle is reported as the static coefficient and alternate. And more accurate test is to use stress strain machine to measure the force required to pull a weighted specimen along a flat surface. A stress strain machine will be give both static and dynamic coefficient values. So we completed here our chapter number 23 for you. Thank you for your valuable time. So friends, we have completed our chapter number 23 and we will move forward to our next video on a different chapter. Until then, we request you kindly subscribe our channel, like and share. Thank you very much.